Good day everyone. This is the homework for inverse kinematic for equation 4.6. So this is the mechanism that we would need to have an equation. So first thing we need to do is to have analyze the equation so that we can have the parameter table or the DH parameter table. So including the link twist, link length, link distance, and the joint angle. So if you already have your table, so you need to consider also the rotational matrix about x, y, and z. Then this is the general equation or formula for the DH parameter. So for the DH parameter, you need the translation and rotation. So translation of z and rotation of z, and also the translation and rotation of x. Then substituting the value, you need to multiply these two matrices, then these four matrices together, so that you may, so this one is the first matrix that you multiplied. So right after multiplication of these four matrices together, this is the form that you need to substitute each row from the parameter table. So substituting the value of the first row, so it you will have the matrix or the translation of the first frame in terms of the zero frame, because what you need to do in the inverse kinematics is you need to have your translation and transformation of the tool frame to the or the end effector frame to the base frame. So the tool frame, I'll just get back. So the transformation matrix from this frame, from this frame, the tool frame to the base frame. So substituting the value of the first row, so you will be substituting all these values to the form or the formula derived. So substituting each value, you would have this matrix. So substituting the value of alpha 1, so alpha 1 and theta 1, as well as the value of d, which is equal to 0. So cosine 0 would be 1 times sine theta 1 in this part. So substituting the value of sine 0 as 0, then you will have this value of a matrix. So the transformation of frame 1 in terms of 0th frame is equal to cosine theta 1 negative sine theta 1 0 0 sine theta 1 cosine theta 1, this is theta 1, cosine theta 1 0 0 0 0 1 0 0 0 0 1. So again, substituting the value for second row. So the substituting the value of substituting the value of the second row, you will have this frame or this matrix. So again, substituting each value for alpha and theta, so you will have cosine theta 2 negative cosine 0, which is equal to 1, sine theta 2 sine 0, which is equal to 0, sine theta 2 link 1 or L1 cosine theta 2. So and so forth. So sine theta 2 cosine 0, which is 1, cosine theta 2 negative cosine 2, sine 0, which is 0, then L sine theta 2. So again, substituting each value, you would have the frame 2 in terms of 1, or the transformation of frame 2 in terms of 1 is equal to this matrix. So again, doing the same equation or same matrix, substituting this to the third frame, so we are done with the substitution of the second frame. So now substituting this to the third frame, we can have this matrix. Substituting each member of the frame with alpha 3 and theta 3 plus the value of A and D, so we can have this matrix. So this is the matrix for the transformation of the frame 3 in terms of 2. So having the 3 transformation matrices, we can derive the inverse kinematics or the transformation of the end effector frame in terms of the base frame. So this is going to be done by multiplying each of the transformation matrix we have calculated or we have done. So doing that, so multiplying this matrix with this matrix, we can have this equation. Since we have this is shorthand, and there could be much simpler shorthand or formula by using cosine and sine law. So for the cosine, there is a formula that cosine of these two angle A plus B is equal to cosine A cosine B minus sine A sine B. Or on the other hand, we have cosine theta plus, or quantity theta 1 plus theta 2 is equal to cosine 1 cosine 2 minus sine theta 1 sine theta 2, or equal to the negative sine theta 1 sine theta 2 plus cosine theta 1 cosine theta 2. So cosine theta 1 plus theta 2 quantity is equal also to this shorthand cosine theta 1 2. So we can actually, there is missing from this one. So there is missing sine, or simply s theta 1. So we can use this formula for this first equation. So, or L1 cosine 1 sine theta 2 minus L1 sine theta 1 sine theta 2 is equal to L1 times the quantity cosine theta 1 cosine theta 2. Oops, sorry. This is cosine theta 1 and cosine theta 2 minus sine theta 1 sine theta 2 is equal to L1 cosine 1 2. So for the trigonometric formula for sine A plus B is equal to sine A cosine B plus cosine A sine A. Substituting the theta 1 and theta 2, we have sine theta 1 plus sine theta 2 is equal to sine theta 1 cosine theta 2 plus sine theta 1 sine theta 2. So therefore, negative cosine theta 1 sine theta 2 minus sine theta 1 cosine theta 2 is equal to the negative of sine theta 1 plus theta 2. So negative sine theta 1 2. So there could be used in this negative sine theta 1, 2. Then here we can have cosine theta 1, 2. So, and here we can have L1 cosine theta 1, 2. So, am I correct with this? So, there you go. Cosine 1, 2. Okay, that's good. Then the next is, we need also to substitute the values. So this is sine theta 1, 2. Then this is, however, this is sine cosine. So this could be cosine theta 1, 2. So there you have it. Just substitute all values, then you can have this matrix. This is going to be the multiplied translation of frame 1 in terms of 0 and times the multiplied by the translation of 2 in terms of 1. So you can also write this one, the translation of 2 in terms of 0 multiplied by 2, or translation of the 2 in terms of 3. So that's also same with this matrix. So the matrix that we have derived from the equation, from the substitution of values multiplied by the translation of the t translation of in terms of 3. So 2, or am I doing it right? Oh. So 3 in terms of 2. So there is the matrix that you need to multiply with the first. So again, after multiplication, multiplying this value by this, then multiplying each element, so you can have the transformation of the end effector frame in terms of the tool frame. So you have the long values. So from trigonometric formula again, we can substitute this this value to cosine theta 1, 2, 3. Then this one. So again, for the trigonometric formula, so this formula can be substituted to cosine L2 cosine theta 1, 2, 3 plus L1 cosine 1, 2. So that can be transformed to L2 cosine theta 1, 2, 3 plus L1 cosine theta 1, 2. I thought this is 1, 2 cosine 1, 2. So this is quite wrong. This is 2. So then substituting this value, negative cosine theta 1, 2 can be derived as sine negative sine theta negative sine theta 1, 2, 3. So then the next one that we can is also cosine 1, 2, 3. So this one is also cosine 1, 2, 3 since then another one, the last one is this one, which is derived from this one. So substituting the value of L2 sine 1, 2, 3 plus L1 sine theta 1, 2. So there you go. There is that is the equation 4.6 derived from the mechanism or the schematics of the given from the book. So thank you.